Alright guys, welcome back. 6.2 is all about the unit circle. The unit circle is a special circle. It's a circle with a radius of 1 centered at the origin of the coordinate plane. And we're using this to make it easier to memorize those special trig function values at 30, 45, and 60, the radian equivalents, which would be pi over 6, pi over 4, and then pi over 3. And then using the idea of reference angles to find that they're actually repeating those special values all throughout the four quadrants of the circle. Just sometimes they're negative, sometimes they're positive based on the location and which trig function we're actually talking about. This skill will be very useful, that you can be able to say what's the sine value of an angle that's not 30, 45, or 60, but it's based on that, so like sine of 120, without having to think about it too much. Especially if you're going to take a class like AP Calculus in the future, being able to recognize that kind of stuff instantaneously will be very, very useful. Now, your 6 trig functions, so we know about sine, cosine, and tangent. We're now going to start exploring the reciprocal ones, cosecant, secant, and cotangent. So based on the unit circle, the sine is the y-coordinates of the coordinate point at that particular location on the unit circle. So there'll be an angle of 30 degrees. We'll have a certain coordinate point location. The y value is sine. The x value is cosine. Tangent is y over x, assuming x is not 0. If x is 0, then it'd be undefined. And then cosecant is 1 over y, secant is 1 over x, cotangent is x over y. And again, each of those, like the tangent one, if the denominator is 0, then that function would be undefined then technically. So what we're going to start off doing is we're going to fill in the entire unit circle. So in class, you guys are going to have a blank sheet of, not really a blank, will be a blank unit circle, not as blank sheet of paper, blank unit circle to fill out, and we're going to kind of work it through together there. So here's your full unit circle. You're going to recognize you have your special angles all inside. There's 3 of them, 30, 45, and 60, and then their equivalents all throughout. And then you also have the angles on the axes themselves, the x and y axis, and then coordinate points based on all of that information. So we're going to start off with the angles, degrees first. So it starts off at 0, and it starts working around to 30, 45, 60, 90. And then what you'll find to help kind of fill in once you know the first quadrant, really you can figure out the entire unit circle after you know the first quadrant, because it's all just repeated. But if you're going from the axis to the next point, you're going up by 30, or going down by 30. So like 0 to 30 is up by 30, 60 to 90 is up by 30, so this would be a 120. And then between the special angles, you're going up by 15. So this would then be 135, 150, and then going to an axis is 30, so that's 180, which makes sense. That's a straight horizontal line. Continuing that pattern up by 30 to make it 210, and up by 15s for 225 and 240, up by 30 to get to the axis was 270, and then up by 30 to get to the next angle, 300 by 15s, and then up by 30 again to end at 360. So those are your degree measurements. Now there's a similar pattern that occurs with the radians, though worst case scenario, though not ideal, you could always just simply convert the radians into degrees and then do it based off that. But the purpose behind the unit circle is to help memorize these angles. And again, memorization is not exactly the most important thing in the world. You want to be able to use it correctly. Memorization isn't always the end goal, but sometimes it's just easier to just have it memorized. It's kind of similar to back to when you guys were in first grade or whatever it was. You memorized 7 times 8 is 56. That way you just know it without having to think about it. With radians, we started 0 radians. Now, the equivalent radians to the special angles, for 30 it's pi over 6, 45 it's pi over 4, 60 it's pi over 3, and then 90 it's pi over 2. And we had already talked about the other radians on the axes when we did the whole reference angle idea. So 180, that's equivalent to pi. At 270, that's 3 pi over 2. And then back to 0 would be 2 pi. Now for the other radians, it's all about symmetry. So the pi over 3s, any radian will be a 3 for the denominator, the ones that are closest to the y-axis, which is the 60, the 120, 240, and 300 locations. And then for each of those, the numerator is based on the next number in line that doesn't reduce the fraction. Meaning we started with pi over 3, after that would be 2 pi over 3, the next number after 1. If we go up by 1 again, we get 3 pi over 3, but that can be reduced, so that's not next. We then go to 4 pi over 3. That's again at the symmetric to the y-axis location closest to it. And then after 4 would be a 5, so that'd be 5 pi over 3. So it's always a numerator that can't reduce with the denominator. The radians that are in the exact middle are based on the pi over 4s. So pi over 4 starts. If we increase by 1, we get 2 pi over 4, but that reduces. So then it's 3 pi over 4. That's the next middle one. After 3 pi over 4 would be 4 pi over 4, but that reduces. So that'd be 5 pi over 4. That's the next middle one. After 5 would be 6, but that also reduces, so that's out. So that'd be 7 pi over 4, and that's our last one. And then finally for the pi over 6s, same concept can apply. These are now what's left over. These are the ones that are closest to the x-axis. So we start with pi over 6. Went to the next one, 2 pi over 6, that reduces. 3 pi over 6, that reduces. 4 pi over 6, that reduces. 5 pi over 6 doesn't, though, so that's the next one. You don't necessarily need to be doing it like this. It's just something I found that kind of a little helpful to remember when you're trying to fill it out for the first time, which ones are which, because again, it's all based on what doesn't reduce with it and what does, ending with 11 pi over 6, which doesn't reduce. And as I said in the beginning, you could just simply convert each of those degrees to radians. That will also do it, or honestly, as in my case, because I've been doing this stuff for far too long, I just have it memorized out of just sheer repetition and usage. So those are all the special angles. So now the quarter points are how we solve a different trig question. So the radius is 1, so you'll recognize on the axes, it's actually going to be 1, 0, 0, 1, negative 1, 0, 0, negative 1. Because on the axis, the 1 value is 0, so the value has to be a 1. Positive, obviously, in the positive portions of the axis, negative, obviously, when it's negative portions. Now, for each of the fractions, you're going to find, or each of the quarter points, you're going to find their fractions. Each of those fractions will have a denominator of 2. I'll zoom in to make it a little bit easier to write this. So each of these fractions are over 2. And the numerators are all going to be square roots, following the pattern of 1, 2, 3. So we have square root of 1, square root of 2, square root of 3. But square root of 1 is just obviously 1, so that's the only one that does not get a square root. And the way the pattern goes is based on whether the x's or y's are increasing. And as long as we know the first quadrant, everything else after that just kind of, follows that pattern. X's are going from 1 to 0, because the x value starts here at 1, and then ends at 0 when it gets to 90 degrees. 0 to 1 is decreasing, so it's a decreasing pattern of 3, 2, 1. And the y's then go in the opposite order. So the x's went 3, 2, 1, y's then go 1, 2, 3. And then you'll recognize from there everything else is going to be based on the symmetry. So if it's closest to the y-axis, it's still going to be the 1/2 of root 3 over 2. If it's closest to the x-axis, it's still going to be the root 3 over 2 comma 1/2. And it's in the middle, it's still root 2 over 2 comma root 2 over 2. The question is whether it's positive or negative. So the x's just went 3, 2, 1. So now they're going to go, they're all over 2 again. It's always over 2. So again, x just went 3, 2, 1. So we can go 1, 2, 3, but they're all negatives because quadrant 2, the x's are negative. Y's just went 1, 2, 3, so now they're going to go 3, 2, 1. They're still positive because quadrant 2, the y values are still positive. Work way down to quadrant 3 here. Again, they're all fractions over 2. So the x's just went in a pattern of 1, 2, 3, so now they're going to go 3, 2, and then 1. They're still negative because quadrant 3, the x's are negatives. And the y's just went in a 3, 2, 1 pattern, so now they're going to go 1, 2, 3. They're now going to be negatives because we're in quadrant 3 here. And then finally our last quadrant, quadrant 4. I'm going to stop zooming in there. It seems like you want to be glitching out on me. So they're still over 2's. The x's just went 3, 2, 1, so now they're going to go 1, 2, 3. But the x's are positive now because quadrant 4 x values are positive, whereas the y's are now going to go 3, 2, 1, but they're all negatives because quadrant 4, the y's are negatives. So those are our special values. Oh, I seem to have noticed quadrant 2 got a little mess up there. That's a little weird. So it's root 2 over 2's there. Both of them are negative. Root 3 over 2 there. Anyway, so that's our unit circle. So we're going to use this to answer questions regarding those special trig functions. The sine, cosine, tangent, cosecant, secant, and cotangent. So the problem is going to ask you, okay, what is the sine of 7 pi over 6? And you're going to have to recognize, okay, 7 pi over 6 is right there. Sine of is the y-coordinates, so it's negative 1/2, and there's my answer. And that's what we're going to be working towards for each one of these things. The goal is, for right now, you obviously have it in front of you, and that's perfectly fine. But as you get further along and more comfortable with this, you should be able to do this all in your head and not need to draw this out or write it down, just be able to do it instantaneously based on you have it memorized. So, sine 135. So you go to 135 degrees. We should recognize that the coordinate point is negative root 2, positive root 2. Sine is the y value, so it's just going to be positive root 2 over 2. That's it. You will never be allowed to use a calculator for this kind of stuff, at least for our class on this kind of purposes for testing here, just because I don't want the calculator ruining the experience where you need to know it. Because you're not going to always have a calculator doing this kind of stuff, later on. So we go to 135, we recognize the y-coordinates, that's all we're doing. Sine 270, that'd be at 0, negative 1 would be the coordinate point. Sine is y, so just negative 1. You'll find that sine and cosine are the two easiest ones to do because it's just strictly the x or y coordinate points, and that's it. The other four, since there are fractions involving x's and y's or just x's, will require a little bit more effort to solve out, but the sine and cosine will be fairly straightforward. Cosine 11 pi over 6, so we're recognizing that's a positive root 3 over 2, comma negative 1/2. But it's cosine this time, not sine, so we want the x value, so it's positive root 3 over 2. Cosine of 7 pi over 4, recognizing that's also in quadrant 4. The x value at 7 pi over 4 is root 2 over 2. The y is negative root 2 over 2. But again, we only want the x value for cosine, so just root 2 over 2. And that's it. So again, those are the straightforward ones. The others require a little bit of calculation because you're going to have to do a division problem. So, 270. We already know 270 was at 0, negative 1. The tangent is y over x, so it's negative 1 divided by 0. Well, when we had first talked about the coordinate points, the rules, there are formulas, tangent being y over x, we said x could not be 0, because if it is, this is really an undefined value. So we can't do tangent 270, that is undefined. Tangent 135, we can do that one though. X is a negative root 2 over 2. Y is a positive root 2 over 2. So we would have root 2 over 2 divided by a negative root 2 over 2. Well, in this case, we can recognize, and as will happen for all the 135 or pi over 4 locations, because y and x are the same, tangent and also cotangent will be 1s. The question is whether it's a positive or a negative one. It's positive when they're the same, it's negative when they're opposites. Here, sine is positive, the y is positive, the x is negative, that's why it's a negative 1 for tangent. Now, cosecant, and you'll also notice 11 pi over 3 is not on the unit circle. So this comes back to then our reference angles and coterminal angle ideas. So here we're using a coterminal angle. It's recognized it's too big, so we subtract by 2 pi, which really is subtracting by 6 pi over 3, which gets us 5 pi over 3. That is on the unit circle, so we're really figuring out what is cosecant of 5 pi over 3. It is the exact same value as cosecant of 11 pi over 3. So at 5 pi over 3, we're recognizing the coordinate point there is going to be a positive 1/2, comma, negative root 3 over 2. Cosecant is 1 over y, so it's 1 divided by a negative root 3 over 2. Now, when we last had that fraction with the tangent, they were the exact same, so they canceled. More often than not, they will not, so we need to recognize it's really, all this really means 1 over y, 1 over x, x over y, whatever it is top divided by bottom. So this is really 1 divided by a negative root 3 over 2. And when we divide fractions, we multiply by the reciprocal. So we get a 2 over negative root 3. Now that's not proper form, so we rationalize it. Multiply by the root 3 and getting a 2 root 3 over negative 3 for the value of cosecant of 5 pi over 3. Now, what's nice about these problems is as I'm sure you're discovering as you're going through some of these already, and as you'll definitely discover as you start doing some more on your own for homework, is because the coordinate points are pretty much there's only really, I guess depending upon how you look at it, there's only really 3 options. 5 really, but some of them are kind of like repeated, but just kind of reversed. So you're really going to get repeat options. You'll recognize anytime it's 1 over root 3 over 2, you can almost always go right to 2 root 3 over 3. You can just recognize that. That's part of where the memorization process comes into play, recognizing, I'm dividing by root 3 over 2. Every single time I do that, I get 2 root 3 over 3. Boom, there's your answer. So there's really not a lot of work that has to be shown for a lot of these things, just simply because a lot of this really, when you get better at it, will be just you're doing it in your head. I'm writing out all the work right now so you can kind of just see where it's coming from, not think it's coming from magic. So that's why negative 7 pi over 6 is really 5 pi over 6. You could do that in your head. I'm showing it to you so you're not like, whoa, where did that come from? So at 5 pi over 6, we have x is root 3 over 2. It's a negative. Y is a positive 1/2. Cosecant is 1 over y, so it's 1 divided by 1/2. So it's really 1 times the reciprocal, 2 over 1, which is just simply 2. So some of them will be nice, because not all of them involve radicals. Some of them are the fraction 1/2, or the integer 1, or the integer 0, so they kind of work out nicely in those cases. Secant of negative 540, again, we got to go work with the coterminal, so we add by 360. We get a negative 180, still negative, so we add again. We get a positive 180. So it's really secant of 180. 180 degrees is at negative 1, 0. Secant's 1 over x, so it's 1 over negative 1, which is just simply negative 1. 840 again is far too big, so we go ahead and subtract by 360. We get a mental breakdown right there. We get 480, and we subtract by 180 one more time, we get 120. So secant of 840 is equivalent to secant of 120. Again, it's 1 over x. At 120 degrees, it's a negative 1/2, comma, a root 3 over 2, so it's 1 over a negative 1/2. Well, we already saw 1 divided by a positive half is 2, so if it's a negative half, it's then negative 2. And that's where, again, the repetition comes into play. Really, once you start doing it enough times, you don't need to keep on doing it over and over again. You can recognize, that's going to be negative 2 because I'm doing 1 over a half. All right, our last one is cotangents. So we have 15 pi over 4. Again, that's too big, so we subtract by 2 pi, which would be 8 pi over 4. That gets us 7 pi over 4. That works. So cotangent of 7 pi over 4 is a positive root 2 over 2 and a negative root 2 over 2. Cotangent's x over y, so it's positive root 2 over 2 over a negative root 2 over 2, which, like before when we had the tangent value involving the same root 2 over 2 top and bottom, comes out to be a negative 1 again. So really, one of the nice ones besides the sine and cosines is tangent and cotangent. At the 45-degree marks or the pi over 4 marks, it's always going to be a 1 or a negative 1. You'll find in quadrant 1 and 3 it'll be 1 because they're the same, either both positive or both negative. Whereas quadrants 2 and 4, you'll find they're both going to be negative values there. All right, so then we have our cotangent of negative 8 pi over 3. So we can recognize that we're going to have to add by 2 pi here. So we're really adding by 6 pi over 3. Which gives us a negative 2 pi over 3, still negative, so we add again. This time we get positive 4 pi over 3, so we're good to go. So cotangent of 4 pi over 3 is going to give us a negative 1/2, comma, negative root 3 over 2. So it's really going to be negative 1/2 divided by a negative root 3 over 2. This one does things don't cancel nicely, so we're going to have to go through the basic arithmetic of this. Recognizing it's top divided by bottom, so it's top times the reciprocal of the bottom. Negatives cancels, 2's cancel, it's 1 over root 3, which we then rationalize into root 3 over 3. And there's that last one. All right, so depending upon what you end up getting for the coordinate point will determine what the final answer is. There's a couple I technically didn't go through in this video here. A couple different options. It's possible to just get to root 3 as a final answer, root 2 as a final answer. I think that covers all of them really. And obviously the different possibilities of positives and negatives. All right, so it really just comes down to practicing and then memorizing the unit circle to the point that you don't have to constantly keep on creating it. All right, so make sure you're careful and conscious of that idea. All right, so that's it for 6.2. I'll see you guys next time with the idea of inverse trig functions.